what it does. More props.
I figured it out.
Grab backward. Now let's all decide on which way should we shade, left or right?
Between doesn't matter.
There's no between. I did that intentionally. Who said between? That was good. I did that intentionally. Own up, Randall. Very good. I did it intentionally. Explain why soon. Left. We're shading left.
You switch. Hey, I do what I do.
Percent?
Now it's asking you to input a percent as a decimal.
0.25.
0.25 or 1/4. That's a decimal. 0.25. Go ahead and put 0.25 in. We can do that one next. Okay. I shaded left. Now, however, if you guys picked right and put this in,
Shaded the right side of
it
it.
would do that.
Oh.
Ah, fancy, fancy. However, and Riley, I remember you were upset last time because I didn't make the bar go all the way down to the bottom. And this is why I told you this was the reason, the main reason I did it was to have this guy right. Notice what it's telling you. It's saying Z equals negative 0.67. Sorry.
What does Z
What does Z
mean again?
mean again?
Isn't that like an X and
Is it, well, right, it's
Is it data on the
a
number
sight,
line?
or to count, Zahl in German. This is probably why you see. It's a point on the number line, yes ma'am. So all these numbers on the standard normal curve are called Z-scores. If it has an average of 0 and a standard deviation of 1, it's called the Z-curve, the standard normal curve, the standard normal distribution. So the Z is telling you, without being able to label it, this little point right here is negative 0.67. Negative 1's over here a little bit further, just symmetric to this one, right? So what does that mean? What did you just find? Remember what percentage you put in? You put in 25%, right? So you know that this is 25% of the curve right here.
Yeah, the rest is
What did you just find with the Z-score of negative 0.67?
the point where it starts becoming.
Riley, go ahead.
The first very.
Yes, ma'am! Can I use a different term instead of deviation? You found Q1, or the 25th percentile, didn't you? You found the 25th percent. If you're thinking of a box plot, you just found the part of the box plot that goes like that. The 25th. You haven't used this term in like 3 weeks or 4 weeks. It's okay. But this is the 25th percentile. You just found the Z-score that separates the bottom 25% from everything else.
And that's only if you do it backwards?
Well, it's the easiest way to find it. So Davidson asked a very good question. It's only if you do it backwards. You can actually do it forwards, but it requires too much guessing and checking to hone in on it. That's why I wrote the backwards part. It gets you directly there right away mathematically. Where would the 50th percentile be?
At 0.
A 0.
At 0? At 0? Is everybody buying that?
Yeah.
Let's find out. Let's make sure we understand why it's got to be at 0. It doesn't look like it should be at 0. Look how narrow that is.
But because it has
Look at, who said look at how high it is? Oh, Sandy, making me very proud right now. Hey, thank you. Look, see, my question was, I was very nervous. If negative 0.67 is the 25th percentile, how can 0 be the 50th percentile? It's right next door, but then Sandy goes, remember, it's not about this, it's about this, yes! So the box is going to be right here, isn't it? The box is going to be right there. Good, 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 good. So that area right there is an additional 25%. Fair?
And then the next spot over is the next 25%.
And where's it going to stop? Faith! What's the next Z-score that the next 75th percentile would be?
0.67.
Positive 0.67, yes. Right about here. Which would be this part of the box plot, yes. Well, too far even, that's even too far. Which would be 25% more. And then last but not least, and technically speaking, that whisker goes off infinitely.
So should that be an arrow again?
Technically speaking, yes. But in real data, when you collect real data, this is all theoretical standard normal distribution. When you collect real data, there always is a biggest and a smallest. And sometimes they're unusually big and unusually small and it becomes outliers. But yes, exactly. Now, can you get these numbers, the 0 and the 0.67, used in the program?
Why not?
Of course. I love that. Why not? So, more props. Do it backwards. Let's shade left again. And we'll shade right the last time. So suppose you wanted to shade, oops, I should probably erase all this stuff.
How do you go back?
Did you do left
Just
or
keep
right?
pressing enter. I did left again, yes. Keep pressing enter and eventually it'll say more probabilities, more props. Just keep selecting enter on that. Percent, 0.5, what's that? Look at that. Shoot. Stops halfway. It tells you the z-score should be 0. There it is right there. Please, Riley, go.
If it's 0.5, why is it shaded on the negative side?
Because I chose to. I can also choose to shade it on the positive side by shading to the right.
Oh.
Very good question, sister. Very good question. You could also, watch this.
Is that the difference between the left and the right?
Yes, ma'am. Which tail does it shade into? The right tail or the left tail? Yes, ma'am. So let's shade to the right this time. And also shade 50%. And then let it fill it in. Here it comes. Shoot, shades over there. Now notice, the reason, whenever you shade right, I put the z-score on the right side, left on the left side. I did that intentionally because I wanted the negative sign to jump out at you. A negative z-score means it's below average. A positive z-score means, and a 0 z-score means it is average. Good. Really what you've done is you've broken up the curve into a number of regions. Good. Fair enough? Is that believable? Makes sense. Good. This is, yeah, good. So that last percentile, the 75th percentile, so to speak, it's backwards. So if you're ever looking for a percentile problem, it's always backwards. So do you see why I'm calling it backwards now? Because it makes sense as to why I call these backwards and not forwards. Good. Callan's like, yes, good. I've made these phrases up. I've made them up. Nobody else calls them that except me. But my students love it because a forwards problem is when you have the z-scores and you get the areas. And a backwards problem is when you have the area and you get the z-score. That's why I call it backwards. You're looking for things in reverse order, so it seems normal to call them backwards. Is that fair? So let's go with shade to the right, and we want to shade 25%. And here it comes. There's your 0.67. Now, you do realize if you had shaded left, 75%, because there are a lot of sneezes and coughs. You guys stay healthy on me. If you had shaded to the left 75%, you would have gotten the exact same z-score, wouldn't you? If you had shaded left 75%, it's the exact same z-score that cuts off the left 75% as the top 25%.
But the other side would have been shaded off.
Yes, ma'am. You would have shaded from here down as opposed to from here up. Perfect. Thank you. Good? Fair? Maybe. Getting there. Ish. That's the standard normal distribution. And it's fantastic. We're always going to refer back to this program while we work on normal distribution problems.
Are you going to show me how to use this in real life?
Oh God, yes! Starting like 30 seconds from now. The problem is, well, here's why may I edit that statement?
Yes.
I can't make this curve work in real life. And here's why. I can't think of anything in the world that has an average of 0 and a standard deviation of 1.
But you would put the actual value, right? Like we did with this.
Yes, thank you. Yes, Alicia's got it. So what we do is we learn something called a transform. To transform the real life data to transform into this one. I think I remember I told you why I built you this program. I don't want you carrying around a book with infinite pages. Because theoretically speaking, for every combination of average and standard deviation, you'd have to have a differently shaped curve. Rather than dealing with that, let's instead get the other curves to come meet this guy on his own terms. Here's an example. We'll come back. Because I do, yes, Dave. I mean, all the rest of the term basically is learning how to use this in application. So here's one way of looking at that. Okay. Don't write this down right now. We're going to come back to this one. Take a look at it though.